So when we are doing function operations, the first thing is, in order to do anything, we have to define our functions. So I'm going to define f of x as 3x minus 5. And I'm going to say that I'm going to choose g of x to be x squared plus 2x minus 3. So when I see do something with your functions, first thing is x itself, these x's, these are just saying what you're using as your variable. So if I look at x over here, f of x, I see f at x. And then in my equation, I'm using x as my input. G at x, I'm using x as my input. So essentially, that's not really a variable in the sense of you're doing something with it. You're just saying this is what I'm using in the equation that I created. Okay? So right now, if I look at A, there is no math I can do on this problem right this second because I have not actually got an equation. So I have f, and f is saying, hey, go find the equation that I'm going to use. F says, hey, I've got a list somewhere. So I'm going to replace this f of x with what I have it as equal to, and that is 3x minus 5. Also want to note, it's very important because probably save you a lot of grief and trouble and making errors. You want to use parentheses for input. So then it says do a plus sign. So I say plus, so what am I adding to it? Well, I'm adding whatever g is. So what is g? X squared plus 2x plus, not plus, x squared plus 2x minus 3. And now I can actually do math on it. So from here, I'm just going forward and doing math. So I look at the first set of parentheses, nothing's happening, so I'm going to drop them. Look at the second set of parentheses, nothing's happening there either, so I drop them. Now it's a case of just adding like terms, and I'm almost done, so I'm going to say, okay, j of x is equal to, and I like to go in order of highest exponent on these types, so polynomial sets. So x squared, there is no other x squared set, so x squared is my final. If I look at the next one down, so there's an x term, 3x. There's another x term, 2x. So 3x plus 5 plus 2x is 5x. And then last, I'm looking at numbers. So minus 5 is a regular number. Minus 3 is a regular number. If I add those together, I get minus 8. And so that is my answer. I have pulled in my functions and I have combined my like terms. So let's move on to B. Same idea of doing f of x. So I put it in parentheses. Minus, because that was already happening. That's the operation that's happening. And then g of x, x squared plus 2x minus 3. So here I am 3x minus 5 minus x squared plus 2x minus 3. And then I start evaluating. Nothing's happening with the first set of parentheses. There's nothing out in front here. There's nothing, no values, no operators. So those parentheses are essentially not being used, so I remove them. Now what I see is a subtract sign. And I am subtracting this whole entire equation because I'm subtracting g of x. So what's important is that this is subtraction of everything in the parentheses. So I need to distribute that negative. So minus x squared minus 2x plus 3. When I subtract a positive, it becomes negative. When I subtract a negative, it becomes positive. Essentially, that negative changes all my signs. Now, once again, I'm back to, okay, I've taken care of everything. I don't have any more parentheses. I now evaluate based on my like terms. So first, x squared, don't have any other x squareds, so negative x squared. Second, x, because it's the next exponent down, 3x minus 2x is plus x. 3 minus 2 is 1. And lastly, negative 5 plus 3. And I will get negative 2. And then that is my final answer. So there is A and B. Let's also look at D. Not going to worry about C. C is, we've already talked about that type of problem. So on D, I'm doing something a little different. So I've got a 2. And what's happening here, if I don't see a symbol, is multiply. So 2, and I'm doing that with the parentheses, 3x minus 5 plus 3 x squared plus 2x minus 3. So I'm ending up, so 2 times f of x, 2 times f of x is going to end up as 2 times 3x minus 5. 3 times g of x is going to end up as 3 times x squared plus 2x minus 3. Now I can actually do some math on this, because remember, if you have just function names, f, g, h, whatever, there is no math available to you, pretty much. So, distributing the 2, I'm going to get 6x minus 10, 2 times the quantity 3x minus 5. Next, 3 times the quantity x squared plus 2x minus 3 will give me plus 3x squared plus 6x minus 9. Now, since I've taken care of all my parentheses, I can combine my like terms. So now the process is the same in the end, always simplifying and combining like terms. I have 3x squared is my only x squared term. 6x and 6x, so 6 plus 6 here, plus 12x. And then last, the numbers, so negative 10 minus 9 minus 19. And there is my answer. So if you have other numbers running around, these are just regular values, and they do whatever it says to do. You just have to make sure that you are pulling in the actual function set before you try and do any actual math. Okay, the last thing I want to talk about is the multiplying. So we've talked about addition, subtraction. If we have 4, 2, or whatever, just do what it says. So the last thing is multiplication. So what I want to do is multiply. Again, f of x, you cannot do any math on that. And this isn't x times x either, because this is my entire quantity. That's saying that is a particular equation with x as my variable. So what is it actually? 3x minus 5. G of x, find the equation for g with x as the variable. X squared plus 2x minus 3. Then from here, obviously, we then again need to, now we're going to be distributing through. We have multiplication with plus minus sets. So I want to distribute through, and I'm going to distribute through first on the 3x. So 3x distributed through the second set of values. So 3x times x squared is 3x squared. 3x times 2x is 6. Oh, I made a mistake. 3x times x squared is 3x to the third. So I had I messed up on my exponent. 3x times 2x plus 6x squared. 3x times negative 3 minus 9x. So I have successfully distributed through on the 3. Then I need to successfully distribute through on the next term, which is negative 5. So for these, I like to stack my values if I'm doing it this way, because I have a lot of numbers. It's a little easier if they're not in just big one long line. So on the 5, I'm going to distribute that. I'm negative 5 times x squared, negative 5x squared, negative 5 times 2x minus 10x, negative 5 times negative 3 plus 15. Notice I did move this over, and the reason why is because I'm trying to stack my like terms. So basically what I'm trying to do is get my like terms kind of on top of each other, and most of the time this is going to work out pretty nicely. So I now just need to add together. So j of x is 3x to the third, no like terms there. Then I have 6x squared minus 5x squared plus x squared. And I have minus 9x minus 10x, so minus 19x, and then plus 15. For right now, since we're just doing introduction to this, if you end up with a division set, we're not going to worry too much about simplifying that. So for example, if I actually had j of x equals f of x divided by g of x, just write that with what it is. So f of x is 3x minus 5 over g of x, x squared plus 2x minus 3. So a full quantity over a quantity. Nothing is there. Generally, there's nothing to do here. Okay, so my final answer, since nothing's happening, I can't reduce anything, no common factors. A factor is the full set, so this is the factor, and that's what I need to reduce. Since those don't match, there's nothing I can do as far as making that problem look easier to deal with. So my final answer is 3x minus 5 over x squared plus 2x minus 3. And then I forgot to box that one. So there's my first answer of multiplying and my second answer of division. And so that takes care of your 4 major operations: how to add, subtract, multiply, and divide with various function statements. These particular functions were defined fairly simply because they're just polynomial. You don't have any weird division or square roots or anything else going on. So this is an introductory set to function operations.